Sophie or styrofoam? Does it taste like water the way water should taste?
Exactly.
So it's without all the but if you choose this one, it says
Morning, everyone. Can you hear me? Is it all working? So, welcome to you all. Welcome to both U.S. and Danish guests from municipalities, consulting firms, from universities, and especially to our Danish guests who are located in Seattle. You are at the University of Washington, which last year was voted the greenest university of 118 institutions in the U.S. By the Sierra Club, largely for our energy measures, and so waste sourcing as well as education. Didn't quite get first this year, but we're in the top 5. We're in the College of Built Environments, which is architecture, landscape architecture, urban planning, and construction management. And we collaborate with engineering as much as we'd like, but we do that. And my Green Futures Lab is up in that corner, second floor. And hopefully today you'll get a chance to either go up there and peek out at our new green lab, or if you want some fresh air to go around and look at it with the garden. These 2 big panels that move on a track so that they can be maintained and irrigated by water from the Gould. My name is Nancy Rottle. I am an associate professor in our college here in several departments. I teach urban hydrology as well as design, and I direct the Green Futures Lab, which focuses on infrastructure, research and design. And I think, as you all know, green infrastructure is increasingly being recognized as an approach that communities can choose. I'm going to quote the EPA now, the Environmental Protection Agency, to maintain healthy waters, promote multiple environmental benefits, and support sustainable communities. This past year that the EPA was recognizing that green infrastructure is a viable method, and partly not only for stormwater, but for other benefits as well. So we use this term a lot. What really is green infrastructure? In 2007, a European team did a literature review, and they came up with a definition that suggested that it's considered to comprise of all natural, semi-natural, and artificial networks, multifunctional ecological systems in, around, and between urban areas at all spatial scales. So very broad, very inclusive. And then, of course, we also use it to signify a more natural systems approach to water utilities. We call it high-performance infrastructure, or in Seattle we call it green stormwater infrastructure. And we heard that term a lot yesterday on the tours in Seattle and the lectures. So in my Green Futures Lab, we regard that urban green infrastructure is both these green spaces in cities, as well as the utilities that incorporate that systems approach to provide services that can make cities livable, healthy, and environmental solution rather than part of the problem, and providing a magnitude of benefits. And as I said earlier, the EPA is recognizing that green infrastructure can provide benefits. And on the website, it says not only stormwater management, but also flood mitigation, air quality management, much more. So we all know about much more. And that it has an ability to simultaneously meet many objectives, that it can simultaneously meet many objectives, making it a viable and cost-effective solution to solve more than one problem. But the question is, do we really know that it's providing these multiple benefits? And is it worth the expenditures to essentially change the way we engineer our cities? What are the costs of green versus gray? And unlike gray infrastructure, which we can know somewhat clearly if it's working or not working, how can we trust it and know that it's performing for stormwater as well as for other human environmental needs? And, well, we've we're starting to get many studies that demonstrate green stormwater infrastructure's efficacy in treating stormwater. Making the shift to new idioms of urban form is never easy, and political and economic decision-making demands evidence that the various benefits that promoters are touting are actually measurable and demonstrated. That's what today's symposium is really focusing on. And it's meant to get you thinking about how to evaluate the values of green infrastructure, to acquaint you with some of the tools, and perhaps answer some of the questions that you have about the costs and benefits. So first of all, we're going to hear from Emiko Takahashi. Emiko is an economist from Seattle Public Utilities, and she says that she is making amends for her work on Wall Street. And I'll introduce everyone, Emiko, but she's going to give a talk on green versus gray and outline her analyses of the costs of Seattle's approaches to natural drainage, which has been going on for a decade now, and green stormwater infrastructure, and answer some of the questions that you were asking yesterday about cost that I certainly couldn't show those. Then we're going to step back to take a broader view of green infrastructure. Ryan Wilson of Chicago's Center for Neighborhood Technology will give you that organization's perspective and results on the multiple values of green infrastructure, including some really useful tools that are available to all of you to evaluate the performance of green infrastructure features and systems, and show you some examples. And this document right here, which I just downloaded this morning and printed off, it's actually in color, is one that you all have access to. Brian is a registered landscape architect. He's led numerous demonstration projects in design projects with water in the Chicago area. And Chicago's climate is a little more like Copenhagen's. It's colder in the winter, windy, and it gets some rain. It's here where it's drier. Then next, we'll have a little break, and then we'll hear from Dr. Mark Buckley from Econ Northwest, who is an economist working in Eugene and Portland, Oregon. And Mark specializes in natural resource and environmental economics, and has applied some of the methods that are in CMT's Green Values Benefits Guide. So he'll talk about how to ensure rigor in evaluating ecosystem services, green infrastructure, finance, and how the benefits information can actually help communities move from great to green. I mentioned a break between those two. There'll be coffee and some snacks. I also just want to take this opportunity to point out where the restrooms are, the toilets. So the women's is in this corner, the men's is in that corner, both this floor and the second floor. So anytime you want to get out and get coffee or something to eat, use the restrooms, feel free to do that. So after Mark speaks, then our U.S. participants will be familiar with the Danish situation and context. Lecture, a short talk by Dr. Marina Bergen Jensen, who's one of the leaders of the group, professor at the University of Copenhagen, who specializes in water quality. And that's so that we can all participate in roundtable discussions to explore how some of the methods that our Danish guests are seeing in Seattle, Portland, and San Francisco can be applied in their situations. So that's to acquaint the U.S. participants so that you can better And to that end, we want to make sure that by the time we get to roundtables, that your tables are mixed. Every table has U.S. and Danish participants. And it'll be about lunchtime. We'll have some sandwiches for you. We'll continue that conversation until our final lecture from Dr. Curtis Hinman from the Washington Stormwater Center. And I'll just introduce Curtis at lunchtime and tell you more about it. So I just want to take the opportunity to thank everyone who's been so instrumental in pulling this all together. City of Seattle yesterday for giving tours and lectures, and for bringing Dr. Buckley here. University of Copenhagen with the Danish Technology Center that's supposed to fund this. So that's been a grant that's supporting a lot of the Danish touring that Antje and Marina have put together. And Concord very much helped when they were on this end, helped us organize and plan things. And then our student help that we just couldn't have done without it. Andrea, who's had all this set up and drove yesterday. And Tosh here. Tosh has been helping with the drivers and Portland. And then several drivers. Anne's been both days. Audrey yesterday. Mary's here. Harvey today. Jess and Betsy. So thank you all for all of your help, all of your interest, and your work on advancing green infrastructure. With that, I'll turn it over to Monica.
Welcome to Seattle, everyone. And I'd like to thank you for this opportunity to talk. I also want to thank Nancy for picking the title of my presentation for me. She told me green versus gray, and that told me everything that I needed to know about what you wanted to know about economics. Okay, so I've been the economist at Seattle Public Utilities for 10 years, and my specialty is drainage and wastewater. So probably want me to tell you very simply that green is cheaper than gray and be done with it. But unfortunately, I'm an economist on the one hand, on the other, two hands. And so I'm here to tell you that it depends. And I think there are major factors that make green cheaper than gray at times. So there's goals, your settings, and partnerships. So goal is, green infrastructure is used occasionally for volume control, sometimes for water quality. Also, your setting. What are your soils like? Portland soils are much more porous than ours, or penetrable than ours. They don't have steep slopes like we do, and you have your own natural setting. Density, if you have a downtown area versus a rural area or industrial residential area. And then partnerships. We have found that private developers are willing to help us out. There's also landscaping. You can get people to put these on their private parcels. They will maintain them. So my talk today is going to be about this. It's about when is green cheaper than gray. And I'd like for you to put on your personal hats and think, okay, so imagine you have your own like a parking strip in front of your house and you want to do something to manage the stormwater. Are you immediately, because you're a green professional, going to pick green, or are you going to consider everything? Are you going to consider the gray? And I think you would if you're thinking with your own money. And when I do these projects, I think of my ratepayer. He's not you and I, he's possibly a working mom, trying to make the rent. Would she want me to buy this green versus gray? The answer would probably be no, the green is more expensive. So think about it from your perspective. The other thing that you might think of is, boy, if I could get the street people, or the city to pay me, give me an incentive for one of the options, you might pick that one. So it's not as easy to say green versus gray. It depends on what soil you have outside, what funding you might be able to get. That's what I want you to take home. And you'll see that in our projects. That's how SPU thinks about its projects. So a little bit about the goals at SPU. In 2002, we started green stormwater infrastructure for creek protection. This is a map of our city. And I'll zoom in on the north end. You can see there's a lot of creeks. We have Pipers, Thornton. They are creeks that are part of our stormwater system. So we put our stormwater in there and we were scouring them. We felt responsible, so we thought we will create a lot of green stormwater infrastructure to mitigate those. And those are the projects you went to see yesterday. C Street is in this Pipers area. Can everyone hear me? Okay. Oh, more than my arm. So this is the area that you toured yesterday. A lot of the projects there for creek protection. And on the south end, we also have other creeks. And the High Point project that you saw was protecting the watershed here. Oh, I'm sorry. So our first goals was creek protection. In 2005, we realized biofiltration could also be a technology that's considered green, and Thornton Creek Water Quality Channel was designed, and we also have a project called Swale, which I'll be showing you the economics of. And then later on in 2010, combined sewer overflows, mitigating those and controlling those was an objective of our focus. So we thought we use the green stormwater infrastructure as a tool. So I'm not going to talk a lot about the creek protection because I don't think the Danish group has that much of it, but perhaps water quality and volume control. Okay. So asset management at SPU is a process in which we look at the goal, what are we trying to achieve? We look at all the options, whether they're green, whether they're gray. We look at a huge toolkit of options. And I think that is the strength of SPU, is when we look at CSO's mitigation, we look at storage, tunnels, can we transfer it downstream to somebody else? Can we treat it? On the gray side, we'll look at different technologies. Rainwise is a program where we ask people on private parcels to mitigate stormwater. We work with developers and all the different, we have wet ponds, filtera units, media filtration, biofiltration. We'll look at a huge toolbox and with no preconceived notions of what we should do, whether it's green or gray. To give you an example, we had a recent brainstorm, and it's not just engineers. We asked the field people. We had a brainstorm where the field operations people, the economists, the engineers, the decision makers are there, and we came up with 143 stormwater projects we could do in the next few years. I mean, things like, make golf illegal in Seattle so that we don't have fertilizers going into our golf courses. I mean, anything was okay. So I think the message there is look at your options, don't limit yourself, and you'll see where some of the opportunities come in. So the next thing I want to talk to you about is life cycle costs. And as an example, I wanted to give you, these are all green technologies. I wanted to show you what life cycle costs, what I mean by life cycle costs. So Rainwise is our program for private properties. People can get incentives to put in rain gardens, disconnect the downspouts, or put a cistern. And then our right-of-way projects are bioretention, rain gardens, and forest pavers. So I think a lot of people like to look at how much does it cost for me to put it in. And my metric here is how much does it cost to mitigate 1 square foot. And a lot of people might stop here and say, well, if the choice, I would do a downspout disconnect. Keep in mind, you have to think, could you do it? In Seattle, you can't do it all the time. You could be flooding out the guy next to you, or you could get a steep slope and you can slide down the hill of your house to the level of your stormwater. So keep in mind what setting you have in choosing which you might choose. And the Rainwise program is a program where SPU utilities are giving people incentives of $4, up to $4 a square foot, to mitigate stormwater on their property. And so someone comes and says, maybe 100 people come one year and say, great, I want to be in that program, so yes, we enroll them. But what you have to consider as a utility is, I think I have 100 of these Rainwise units, and perhaps, maybe my cisterns start leaking after 20 years, plastic. So I can't really count on him going and replacing it, so I have to maybe incentivize him in year 20 to go out and buy another cistern. So it's replacing his capital asset. Okay. And there's also a little bit of replacing course papers, so they fail sometimes. What we also have to consider is that residents leave the program. Someone buys it, sells his house, and someone else buys it. So we consider just even 2% in a single year, 1,100 people, 2 people leave the program, which seems pretty reasonable. But if you think about it, over 100 years, I'm enrolling 2 people every year. That's going to cost me. So those are costs to having private property. The next cost is operations and maintenance. Who's going to water, weed, and mulch my rain garden? Luckily, on the residential side, we assume that they're going to do it. It's their yard. They'll probably be cleaning up their yards. For us, on the right-of-way, O&M can be pretty considerable when you talk about bioretention and rain gardens. This is establishing the plants, replacing them with dye, watering, weeding, mulching. And just the history from 2002 to 2010 has been that we were first insured of operations maintenance. And we thought, okay, when we put in a rain garden, we'll assume that the residents will take care of it. And we found that that was kind of spotty. Some residents did a fantastic job, and some people just mowed the whole thing down. It was functioning, but it wasn't doing us a lot of good. Then we tried having a contractor do it for us. And we found that our funding went up and down, in a fiscal crunch. Our funding for contractors to go out and do weeding and mowing and mulching was like the first thing to get cut. Or we had a really dry year and we had to spend a lot of time. So I'm going to let you know that operations and maintenance of these are still a big unknown and increasing. Yes?
Okay, I'm going to ask you what is bioretention exactly?
Oh, bioretention.
What we saw yesterday in Ballard, those can be called bioretention cells.
Okay.
It's sort of like a rain.
And what's the difference
Oh,
between...
the question was, what is bioretention? What do I mean by bioretention? And those would be the swales that you saw yesterday, C streets, the Broadview Green Bridge,
Yeah.
their retention and filtration swales.
And what's the difference between the first rain garden and the fifth grade rain garden?
Oh, this one is in my, I put it on private property,
Okay.
and the other one is in the right of way on the street. What is the downspout disconnect? This is, currently a lot of roofs are connected right into our stormwater system, so what comes on people's roofs go right into stormwater. This would be making it go into their yards instead. And it's very inexpensive because sometimes it's just a splash pad, sometimes it's running the line out to further out in the yard to let it run. To have somebody similar. Okay, so I think what I want you to take home from this is a lot of people just look at the initial cost. You have to look at how expensive is it going to be for you to maintain a program or just stuff maintenance. That's what I mean by life cycle. Okay? So I'm going to go through, this is what you've been waiting for. This is the part where it says, is green versus cheaper than gray. The first one I'll do is water quality, the next one I'll do is volume control. And the metric here is we take total suspended solids. Water quality is a complicated, you could think of it as metals, you can think of it as temperature. What is water quality? We use total suspended solids as a metric. And what we try to measure is how much does it cost per dollar that we invest to remove total suspended solids. And here are our green options. The 2 wet ponds are inexpensive because they are large. They're kind of in an industrial area. The biofiltration swales that you saw yesterday are at that $30 mark. Street sweeping is a program where we sweep our streets, and it's very good for water quality, very cost effective. And then the last two are the media filtration, and I'd like to point out that this is a logarithmic scale, it's not just a linear scale. Media filtration is a water quality facility we're proposing in an area where the water table is high, there's not a lot of room for a green structure, so we're kind of being, the setting has forced us to put in a media filtration. So the answer to, is it cheaper, is green always versus green cheaper than gray? Sometimes, depends on the setting, depends on your problem. So this biofiltration swale is specifically for water quality. The natural drainage system in Broadview, remember I talked about creek protection? Its goal is to mitigate the flow. It wasn't, the goal was not water quality. So was it effective in doing water quality? It was very good at creek protection, but not so great at
I think you said that, but I didn't hear. In terms of water quality, you're not talking about hydrocarbons, you're talking about heavy metals?
I'm using total suspendeds as an indicator for other pollutants that might be removed. Water quality is a really complicated, and we just need to pick one metric. And the water quality shows total suspended solids to kind of represent the efficacy of removing metals, other organics. If we had to pick one, that's what it is. If you were looking at other metrics, these might shift around. Okay, this is the combined sewer overflow metric. This is green versus gray, less if you're trying to mitigate volume. And the answer is, okay, let me give you what's on the axis here. One is control volume. How much of a combined sewer overflow are you trying to mitigate? On the far end is large volumes, and on this end is just small volumes, 1,000 gallons or so. And then this side is how much it costs per gallon that you're trying to mitigate. And the answer is, in green, the disconnects and things like permeable pavers, cisterns, and bioretention are easy to put in 1 or 2 units, right? Whereas if you were doing something like offline storage, you wouldn't put in offline storage for just 1 or 2 gallons. You would, wait till you got to a certain threshold. So, and so I kind of think of the crossover as right about here at the 1 million gallon mark. The answer is if you have a lot of volume to mitigate more than 1 million gallons, half the tank is going to work cheaper for you. If you have less, looking at green options is viable given you have the room and the space to do it. Okay, so I think those are the 2 slides I'm most interested in, but I want to give you a case study. This is the biofiltration swale. The purpose of this is water quality. So as you tour around Seattle, I think you went to the LARC yesterday. That's kind of represented by number 8. And there's a huge lake that's over here, and the water goes right through the middle of the city. And you'll see South Lake Union has a right here. You can imagine the stagnant because all the water comes and goes right out of the wall. So water quality is a real problem here. It turns out that this is downtown, and this is a very densely populated area. This is my neighborhood, and I wanted to show you some pictures of its, a lot of apartments, a lot of cars, not a lot of room space to put swales in. And parking is always an issue, and we use our streets for a little more than just parking our cars. We have our block parties, we park our bikes there, and we also try and do some urban farming on it. So you can imagine that this Capitol Hill area is really polluted, and there's a drainage pipe that runs right from this area down into South Lake County. So that's the same. We had a developer whose project was down here, and he came to us and he said, we want to do what's right, we want to mitigate our own stormwater. And so he said, would you like to partner with us? Would you help us fund a swale in front of our place? And we said, you know, you're in the mine, the water gets treated anyway, but we happen to have this really dirty water going right by your site. And we asked, would you be willing to biofiltrate this in front of your development? And to our surprise, he said yes. They said, yes, we consider it. So let me show you what we are working on. This is a biofiltration swale. It's not, obviously not infiltrating, it is a downtown area. And this is sort of the new apartment buildings that he proposes to build. And we're sharing the cost. I mean, he needs to redo the streetscape as part of his development. He gets a benefit of, you know, he can tell his renters and clients that he has this biofiltration swell right in front of his building. So he has those benefits. And we looked at, you know, is it a good option for us to look at partnering with him? And the costs came out. So the options we have are, we put in our own storm filter, that's kind of our representative grade. We would put a swale in with partnering, or do a swale on our own. And these are the construction costs that would have been what we would pay. If we were doing the storm filter, we would have had to buy a little bit of land. But what was interesting is that when we looked at the operations and maintenance of the storm filter, these are filters that you have to change out, and quite expensive. Whereas working with the partner, we were able to share costs. Like, we didn't have to redo the streets since he was redoing the streets. We could split the cost of it. So here's a situation of we had an opportunity. This dirty water going by a place that was getting redeveloped. We grabbed that opportunity. We looked at the gray versus green, and the green came out to be the cheapest. I'll leave more time for questions. Yeah. So I wanted to bring you back to your problem of you're trying to figure out how to deal with stormwater on your little property. Look in your toolbox. That's number one. Look at your options. Don't, eliminate the gray because you don't like it. The other thing is, your choice will probably be defined by your city. And also look for partnerships, as you would do for your own personal project. Do that for your utility project or for your projects for private development, for policies or granting for those. And also look for partnerships and landscape maintenance, because you saw that those could get expensive. So let's also challenge you. I have a challenge for you for the next part. You're going to hear a lot about benefits in the next half of the symposium. And a problem that I see a lot is a lot of people say, here's the cost of the green infrastructure. And along with it, they'll start listing out all the benefits. And they'll say, oh, there's energy savings, there's productivity of your workers, or the aesthetic environment will be better. There's carbon sequestration. And someone will draw a line and say, look, I value these benefits, the total exceeds the cost. And therefore, there's my cost-benefit analysis. And I see it a lot, but my problem is that it turns out that it's the utility that's paying for it. It's my ratepayer. And when you think about energy savings or aesthetics, the energy savings might be going to the neighboring buildings. If property values go up, that goes to the building owners. So I really can't justify to the ratepayer that we're putting in the money and the benefits are going to others. So my challenge to you is, as you listen to these quantifications of benefits, keep in mind that the accounting ledger is that some people pay and other people are getting the benefits. And so I think that's why the partnering is so important, is getting the partners to help fund some of the green infrastructure that we've been investing in. So, questions?
I've heard a lot of different comments about the bioswales along C Street, for instance, in terms of long-term maintenance costs and percentages of heavy metals over time and other issues. Is there, in terms of life cycle costs for bioswales along streets, how often do they have to be cleaned? Or how often do the heavy metals have to be removed?
So the question is, he sees a lot of costs on bioswales, and he hears about the landscape maintenance. Is there a cost to also redoing the soils?
We have heavy metal concentrations on those areas.
Okay, so we do assume in part of the O&M that every 15 years we might be taking out the landscape, redoing the soils, and replacing the soils. That's a cost that's in my operations maintenance.
And in your testing and your maintenance, have you found out that they are becoming more efficient at taking heavy metals or less efficient? I mean, is it?
Are they getting?
Is it?
So they're efficient getting the heavy metals out, and are they working better or less?
Yes.
So unfortunately, I'm the economist in that as a water quality question. I can get that answer back to you.
I've been in there 15 years either, so we need to wait a few more years.
So Nancy's saying that we have to wait a few more years to get conclusive results.